Welcome to the fifth film in our Stairs series. In it, we look at the various load-bearing systems for stairs and how staircases are constructed and supported. In terms of its structure, a staircase is similar to a floor and can be of either solid or beam-type construction. A solid staircase is a solid floor that slopes. It has a greater span width than a floor or ceiling because its true length between bearing points is longer. The load-bearing system used is the same as for single-span panels or beams. Staircases designed as solid sloping slabs can only be made using reinforced concrete. This type of stairway is cast in one piece using formwork either on site or in a concrete plant. As for solid floors, the concrete is reinforced with reinforcing steel. The structural height of solid stairs is measured at right angles to the stair pitch between the lower edge of the stairs and a notional line along the rear edge of the tread. The steps themselves have no load-bearing function. There are two methods of forming the steps of solid staircases. Cast-on or added-on steps, which may be made of natural or artificial stone, for example, are attached to a sloping reinforced concrete slab. Much more frequently, however, the steps are preformed in one piece with and at the same time as the stair slab. Casting a sloping stair slab in situ is very complicated because the concrete has to be stopped from running down the sloping formwork. Solid stairs in which the steps themselves are cast as part of the slab in horizontal formwork are much more common. In beam-type stairs, the stairs themselves form part of the load-bearing system. In stringer stairs, beams called stringers are laid diagonally along the sides of the stairs and form single-span beams that span between the bearing points as in beam-type floors. The steps are positioned between the stringers like secondary beams and transfer the loads along a linear flow path. As with beam-type floors, timber and steel are the materials most commonly used to construct stringer stairs. The stringers are made from steel or glue laminated timber boards. The steps themselves are made from either timber or wooden composite boards or steel plates or gratings. In stringer stairs, the individual steps are fitted to the stringers using one of two methods. They are either inserted into the stringers or placed on top of them. With this second method, the stringers have a sawtooth section that matches the pitch of the stairs so that the steps sit directly on top of the stringers. As with solid stairs, however, it is important to note that the structural height is the width of the full cross-section, only excluding the sawtooth section. Another form of beam-type staircase construction is the mono or single stringer staircase. It uses a single beam-like stringer that supports the center of the treads from below, with the steps projecting on either side in a cantilever arrangement. Due to the bending load on the steps at the bearing point on the beam, the load-bearing system has to withstand significant stress. On the other hand, the minimalist construction of the monostringer creates a very elegant design. A single stringer staircase may be constructed in concrete, steel or timber. The load-bearing structure is the same as for on-stringer stairs. However, the bearing must be a clamped bearing that is sufficiently rigid to take the asymmetrical load of the stairs. Summary. In terms of its structure, a staircase is similar to a floor and can be of either solid or beam-type construction. A solid staircase is a solid floor that slopes. Staircases designed as solid sloping slabs can only be made using reinforced concrete. The steps themselves have no load-bearing function and can be either cast-on or integral. In contrast, the steps in beam-type side and mono-stringer staircases made of steel or timber are load-bearing. Please take a look at the sixth and last film in our Stairs series, in which we explain how stairs are represented in architectural drawings.